Hello, everyone. Thank you so much. Thank you for being here. Thank you for your interest in the topic, and thanks for the organizing team for having us here in this beautiful place. I'm excited to be here. So today we're gonna, if you're a pen tester or maybe a bug bounty hunter, you might have came across AWS Cognito when you're testing for the authentication part of an application or its own authorization. So for me, at one point, I had no idea about how to test AWS Cognito every time I come across it because there were very little resources about it, and it always looked very complex to test. So if you don't know about what is AWS Cognito, it's basically a cloud solution that recently been widely adopted and gaining popularity amongst companies, because it offers a complete solution to handle authentication and authorization for your own application. But just like every cloud solution, they follow what we call the shared responsibility model, which basically means that it's at the end of the day up to the customer to properly configure their solutions. So hence, in this presentation, there were no security vulnerabilities exploited. So it's merely a bunch of security misconfigurations because it's really easy to mess up AWS Cognito when you're configuring it or implementing it. So before we dive into the topic, I just want to introduce myself. My name is Yassine Aboukir. I go by my full name on Twitter. I'm an application security consultant. I do pen testing, security assessments, code review for companies. I'm a pen tester at HackerOne. They're running a pen testing program, so I'm part of that. I'm a member at HackerOne Hacker Advisory Board, so basically represent the security researchers and the hacker community on the HackerOne platform. We make sure that their feedback is integrated into their offerings and that their voice is well heard. So I was a security analyst at HackerOne as well from 2017 to 2019. So I basically triaged security reports for some high-profile companies like PayPal, Airbnb, Sony, etc. And I've been doing bug bounties for a decade now, since 2013. I'm one of the HackerOne top 20 hackers on the leaderboard. And last year, I got the chance to win the MVH title. As you can see there, I look like a UFC fighter. So it was during a live hacking event in Orlando. It was a great experience. So let's get into it. Let me introduce you to the AWS Cognito briefly. As I mentioned earlier, AWS Cognito is basically a cloud solution for handling authentication and authorization part of the application. So basically, it allows you to add like a sign up and the sign in features, as well as to manage the authorization across your application. And as you know, if you've got some like a development background, you would know that designing the authentication system or just the authorization is not an easy task. It's very challenging, especially if you're not using a web framework. So it's really easy to mess it up, especially that you are working with the user data, you're working with, you're managing passwords and managing text-based tokens, federation, etc. So there are a lot of stuff involved in designing such system. That's why there is AWS Cognito, which is a complete solution to use for that. I just wanted to throw this one in here because a lot of people confuse authentication and authorization, but this is important to make a difference. Authentication is basically when you verify that the user is who they are saying, and authorization is basically managing permission and making sure the user has certain permissions to access certain resources or endpoints. So that's basically the difference, or we're gonna need it here. So when we talk about AWS Cognito, we have two concepts that are very important to know. The first one is actually user pool. User pool is responsible for the signing and the sign up part, the authentication basically. So you can think of user pool as a user directory where you can create users, you can onboard new user groups. And we have on the other side identity pool, which is responsible for authorization part. It allows like authenticated and unauthenticated users to grant them access to AWS credentials, which will be used to request AWS services. So user pool is responsible for the authentication. Identity pool is responsible for the authorization part. These are the two concepts to remember. This is a high-level architectural diagram that explains how it works. So basically, here we have the user. They sign in, they provide their username and password. So the credentials are actually checked against the user pool here, as you can see. And then the user pool will return 3 different tokens. They return the ID token, the access token, and the refresh token. And then the ID token will be used by the client to request temporary AWS credentials from the identity pool. As we mentioned earlier, the identity pool is for the authorization. So we exchange the ID token to temporary AWS credentials, which will be sent back to the client, and the client will use the temporary credentials to access AWS services like a DynamoDB, S3 buckets, API gateway, and whatever. So in practice, when you're testing an application, how can you tell if they're using a Cognito or not? It's pretty easy. Like if you're using a web proxy, for example, you can observe different API calls that are being sent to the Amazon endpoint, Cognito endpoint. As you can see here in the yellow API calls, these are sent to the user pool. These are sent when you initially try to log into your account using your credentials. And here in the green color, we have API calls to the user pool, the identity pool, which is responsible for the authorization part, as you can see in the green here. So it's basically easy to tell if they're using Cognito or not just by looking at your web proxy and observing those API calls. All right, so in practice, this is how it looks like. When the user tries to log into the application, they provide the username and password so that they're sent to the user pool, and then they check the credentials if they are valid or not. If they are valid, the Cognito will return 3 GWT tokens, 3 GW tokens, the access token, and the ID token, and the refresh token, as you can see here in the screenshot. So what we will do next is that the client will use the ID token here to exchange it for an identity ID. And the identity ID, once we get it, the client will use it to generate what we finally need are the AWS credentials, as you can see here. So these credentials will be used to grant the user access to further AWS services like S3 bucket, like DynamoDB, and other services I mentioned earlier. So this is how it works in practice. So the first, we're going to talk about the misconfigurations. As I mentioned earlier, it's really easy to mess up the configuration of Cognito because of its complexity, because of the documentation is still very ambiguous. But recently, AWS team has been trying to make it easier for developers to properly implement it. But there are still a lot of relevant and prevalent security misconfigurations that really affects these implementations, as I've seen myself during my bug hunting journey or just as a pen tester. So we're going to talk about the very first security misconfiguration, which is unauthorized access to AWS services due to liberal AWS credentials. This is basically means that the AWS credentials, the temporary AWS credentials that we got back, can be over-permissive, which means that they can unintentionally allow access to other services that the user is not really supposed to access. So, but before we dive into it, when the developer is configuring the user pool, the authorization part, they have the choice to either allow authenticated access as well as guest access. The guest access is unauthenticated access, which means that this is used basically when the company wants to have like a public API and they want to grant everyone public access. So in this scenario, we're gonna assume that we only have the guest access, which means that you have the application, but you do not really have an account on the application. You're just like a visitor. So assuming that we're only a guest, we don't have authenticated access, we have to try to fetch the AWS credentials as we mentioned earlier. So the first step to fetch those 8 credentials is we need 3 pieces of informations. We need the identity pool ID, and we need the client ID, we need the region. These pieces of information are usually hard-coded in the source code. So basically, if you're like testing an app, you want to check the source code because most of the time these three informations are hard-coded there. If they are not, they're either in the JavaScript that is being loaded by the application. And there have been times when I had to fuzz the web directory for potential files, and I would find like a JSON file where the client ID and the user pool ID is stored. As you can see here in this screenshot, this is one of my targets. I literally found this information hard-coded in their JavaScript file, so it was pretty easy to find. So to fetch the AWS credentials as authenticated guest, we literally need the identity pool, the client ID, and the region. So another way to find those IDs is just through your Burp Suite. If you're using Burp Suite, for example, you can just go through your proxy history and look for keywords. As you can see here, these are the keywords that I found in the past, and you can just look up for these keywords to find those IDs that we need. By the way, these IDs are not really sensitive on their own, so you just need to use them as part of a chain. As I mentioned earlier, there is another way you can find these IDs is just by brute forcing the directory. Here, as you can see in my example, I literally just recently found dot environment. I found that the pool ID here and the region client ID was stored in a dot environment file, which I brute forced using FAV tool, if you know it. So most of the time, these information are hard coded somewhere in the app. Also, there is another way you can, if you're like doing automation, you're doing bug bounties on a large scale, for example, you can use Nuclei tool. It's basically a web scanner that relies on a bunch of templates to scan through a lot of assets. So if you have so many assets, you can use this template, which is available on the project discovery repository. You just go to Nuclei templates. It uses a bunch of regexes that matches the pool ID as we would need in the next step. So once we secure the pool ID, mainly in the source code, we will use the AWS client to execute the following commands. We provided with the pool ID here, as we found earlier. We provide the region and we execute the command. Then this will generate an identity ID. So we will use this identity ID in the next step to finally generate the AWS temporary credentials. So you execute again a different command using the identity ID that we generated earlier in order to generate temporary AWS credentials. Now that we have these AWS credentials as a guest, we don't have an authenticated account, if you remember. So we're basically a guest using public information to generate AWS credentials. Once we have them, we want to test if these credentials are over permissive, like they have liberal permissions, or they provide access to different services that you're not supposed to access. How can we do that? Basically, we can use two available tools. They're public. We have Enumerate EM and we have the Scout Suite. I personally use Enumerate EM. It's very minimalistic, and basically it's a great tool. If you want a comprehensive tool, you can use Scout Suite. It's very awesome and provides a great report. But personally, I use Enumerate EM and it works pretty good. So we provide the temporary credentials to Enumerate EM tool. As you can see here, it's a Python script. We give it the access key, the secret key, and the session token that we generated earlier. And the tool will basically enumerate all the permissions, all the AWS permissions that are associated with those credentials. Here in the screenshot, I haven't really found anything interesting. These permissions are basically returning public information, nothing very sensitive, but there are cases where you can find that these credentials give you access to DynamoDB to list their backups. You can find DynamoDB to list tables. You can find permissions to list Lambda functions, and the S3 bucket is the most prominent one that I found. And so you find credentials and you find that they are over permissive and they allow you access to the company's S3 buckets, which is pretty bad. So it depends on your luck. But if we assume that the unauthenticated user is disabled in the console by the developer, which means that no guest access is provided, you will usually receive this error. Unauthenticated access is not supported for this identity pool. This happens when they have disabled unauthenticated access. And this happens also when you try to generate the identity ID that I showed you earlier. So, but in the case that we have authenticated access, assume that you have an application which you have an account on. I mean, you are provisioned with an account, but they are using AWS access. Then it would be really easy to test the AWS credentials, because when you log in to the application, you can observe that the AWS credentials are already automatically generated for you here, as you can see. This is the case if you have authenticated accounts. So you basically just copy these temporary credentials, and you do the same as before. You feed it the enumerate EM tool, the Python script, and it will enumerate if there are any liberal permissions associated with it. So in the authenticated part, it's pretty easy. All right, so the second misconfiguration is an authentication be passed due to enabled signup API action. So there are some applications where you can see the login page, but you don't have any way to create an account, which means that self-registration is disabled. Just the case, for example, of a company that has an internal administration panel, so they don't not allow registration. They themselves provision accounts for their employees. So assume we have a login page like that, or just a SaaS subscription, for example, where you have to pay for a subscription in order to gain access to an account. So, but we can actually be past that. You can create an account on that application, even if you do not have an option to do that from the user interface. How you can do that is just directly calling the Cognito endpoint and then signing up for your account. How you can do that is pretty easy. So from my experience in the console, in the AWS console, the developer has the choice to either allow self-registration or disable it, but it's always enabled by default. So unless the developer disables the self-registration, it will always be possible to create an account just from calling directly the Cognito endpoint. Even if there is server-side checks in the application, you can just call the Cognito endpoint, as you can see here. So we basically need two pieces of information, just one piece of information actually. We just need the client ID of the Cognito implementation. The client ID, as I mentioned earlier, it's pretty easy to be found. You can find it either in the source code, or if you just try to log in, for example, if you try to log in here, you will find it in the HTTP request. You will find the client ID there. So it's pretty easy to find. Once you find the client ID, you just provide it here. You provide your own username, email address, if they're using an email address, or if they're using a username, you provide it with a username and the password and the region. I forgot this one. We need the region, which is pretty straightforward to find as well. So if the sign up is actually Lyft enabled, you will get this message, which means a successful sign up. And this will basically send you a verification code to your own email address. If the sign up is disabled, you will get this error here, sign up is not permitted for this user pool. So it depends on if the developer made a mistake or not. So assuming that you need to verify the account now, assuming that the sign up was very successful. It's, by the way, if you don't want to use the AWS client here, as you can see, like the command here, you can just directly send an HTTP request to the Cognito endpoint, as you can see here. You just want to make sure that the HTTP headers are properly constructed and the JSON format is well respected as well. So you can either use the AWS client or you can just directly call the AWS Cognito. So this here I'm trying to sign up. As you can see, the sign up is not permitted for this user pool. But if it works, it will say this. It will say like, it will send you a verification code to your email, as you can see here. So it's a 6-digit confirmation code that you will receive to your email. But how can you verify it? It's pretty straightforward again. You just call the Cognito endpoint again directly. You provide the client ID. You provide the username that you used earlier to sign up. And then you provide the 6-digit codes and the region. You click OK, and then your account will be verified. If you don't want to use the AWS client again, you can just call the API endpoint with an HTTP request directly. Just make sure this header is present, which is the confirm sign up operation. All right, so that's it. And that's you can create an account, an application that has sign up disabled in public, but because they left the sign up enabled in the console, they're suffering from this misconfiguration. The third security misconfiguration is pretty actually bad. We're going to talk about privilege escalation through writable user attributes. So as a developer, when you're setting up AWS Cognito, you have a bunch of user attributes that you want to collect. It could be a name, it could be a birthday, user email, address, or whatever it is. So basically, Cognito, it provides a bunch of standard user attributes, as you can see here in the screenshot. And you can also, as a developer, you can create your own custom attributes. For example, here, I try to create a custom attribute called user role. So the user role here, I want to store the role of the user in that attribute. If it's an admin, if it's a super admin, if it's a regular user, or whatever. So basically, you have the standard attributes offered by Cognito, but you can also create your own custom ones. So what can go wrong here? The problem here is that unless you actually set the attribute only as readable, it will always remain writable. What does that mean? It means that for the custom attribute that I created, the user role, it's writable as it's readable here as well as writable, which means that the user can update the value of the attribute, which is bad. Assuming, for example, that we assign the regular user role to the user, they can update it and change it to admin, for example, because what we did wrong is that we left it as writable. It shouldn't have been writable here. So that's the misconfiguration. That's the mistake that a lot of developers make, especially that it's writable by default. Like once you create a custom attribute, it is writable by default. So unless you only set it as readable, it will remain as such. So how can we approach this as an attacker or as a pen tester? When you're testing the Cognito, the first thing that you want to do is you want to fetch your own user attributes. Assuming that you are logged into the application, you can observe there is an access token that is being used for authorization. As we mentioned earlier, the access token is usually used to authorize API operations. You can just copy the access token, assuming you're authenticated, and you can just use the get. You can execute this command using the AWS client to get the user attributes. And the user attributes will look something similar to this. As you can see, the family name, the given name, the email verified is set to false. These are my user attributes. And here you want to look for the custom user attributes, because these are usually very secure. So you want to look for custom attributes similar to something like this. Custom is admin, custom user role. But basically, when the developer creates a new custom attribute, it always starts with custom here. It always starts with custom. So you want to keep an eye for everything that starts with custom. And assuming that we have, for example, custom is admin, as a regular user, we want to change it to true. Because it will be, by default, as a regular user, it will be false, and we want to set it to true. What we're going to do is we will try to update that value and see if it was left as writable or not. All right, so we, again, will use the AWS client. We'll use the access token that we got earlier, the region, and then here, we're going to change the attribute name to the user role, or is admin here, this one here. We're going to change it here. And we will add the new value that we want to change it to. For example, if it was regular user, we're going to just write here super admin. So you either have to guess it or again fuzz the application, look at JS file to see what different roles they support in the application. So if it's left as writable, if it's misconfigured, then you will be able to update the role and escalate your privileges to an admin. Yeah, this is literally before this talk was announced. I had a friend of mine who reached out to me because he literally found a security vulnerability on a bug bounty target similar to what I just explained here. So what he did is he used the AWS client to fetch his own user attributes, and he noticed that there was a custom user role attribute that was created by the developer. So he wanted to try to update it, but he did not know what kind of roles were supported by the application. What he did next is he looked at the JS file loaded by their web application, and he found that they actually have a super admin role, which he found in JS file. and he literally just tried to update it using the AWS command as I shown you earlier, and he was lucky because the developer mistakenly left the attribute as writable. So he was able to change it to super admin, and he became a super admin of the app. So it's really easy to misconfigure this, especially that the attribute is usually writable by default. So unless you only set it as readable, you will be vulnerable. All right, another security misconfiguration is updating email attribute before verification. There are scenarios, maybe when you're doing a pen test, maybe when you're doing bug hunting, where you come across an application where you're not allowed to change your own email. You cannot update it. I mean, if in the user interface, there is no option to do that, or maybe there is a server-side or a client-side check to prevent you from updating your email address. Maybe because it was like reviewed manually before, so you shouldn't be able to update it afterwards. But if they are using Cognito, there is actually a huge chance that you may be able to update your own email address by directly talking or invoking the Cognito API endpoint as usual, for sure. So basically, you will use your own access token, which is generated when you log into the app. It's available. You change the region here. And here, you put the user attributes, you put your email here, and the new value, the new email address that you want to change it to. Once you execute it, it will update your own email address. So what's bad here is that a lot of these applications that are not allowing user to update their own email address, they do not actually require email verifications, because they suppose that the user should not be able to update their email, so why require verification? Which is actually bad, because then when you update your own email address, you don't have to verify it anymore, and then you just have access. This is bad, especially if they're using the email address to grant you further access to other services, because there are some applications, they check the email, the domain name part of your email, to see if you're actually allowed, if you should have permission to access other services or not, like internal services. So if you manage to update your email address using the domain part of the company, then you probably escalate your own privileges. But we're going to assume that the verification is actually required. So even like if verification is actually required, there is another problem that arises. What happens is when you update your own email using Cognito, the email value is already changed, has already changed to the new email address, but the email verified attribute is still false, which means that this email address, this new email address is not verified. However, even if it's set to false here, you can still log into your own account with the new email address. That's the problem with Cognito, or that's the problem with this misconfiguration. If you let the user to update the email address and not actually verify it, they would still be able to log into the app using the new email address. Except if you're actually checking email verified if it's set to true or false, which a lot of applications do not really verify email verified if it's set to true or false. So they just look at the new value and they assume that this is the real user. So this is again will result in privilege escalation across the application. But AWS, they actually they were trying to mitigate this issue. So what they did in June 2022 is that they introduced a new security configuration, which sees keep original attribute value active when an update is pending. So this is a setting that you can enable or disable from the console. So what this does is that if it's enabled, it basically says, hey, do not update the user email. The value here, do not update it unless the user has verified that email. But the problem is that, as I mentioned earlier, it was only introduced in June 2022, so a lot of old applications are still vulnerable, and you can just update your email without verification, as I mentioned. So this is a study case. This is a practical study case on Flickr. I don't know if you guys know Flickr. I think it's a Yahoo acquisition. So Flickr basically was using Cognito for the authentication part. And this researcher has found an account takeover using the misconfiguration that I showed you earlier. So this was a report on HackerOne bug bounty platform. This is the report is public if you want to have a look at the details, but I tried to summarize everything here. So what happens is that here in the report, the user victim email address on the Flickr app is max@example.com. This is our victim, and we want to hack their account. So what the attacker did, I have my own account on Flickr. I tried to update my own email address, but I did not have the possibility to do that. Flickr was not allowing me to update my own email address on the app. There were server-side checks. But what I did, as I mentioned earlier, what the researcher did is they directly called the Cognito API endpoint here to update their own email address. So they changed their email address to max with a capital M. This is the same email address as our victim here. But there are two misconfigurations that Flickr suffered from. The first misconfiguration is the email attribute was left writable. So in the console, they forgot to set it as readable only. So the researcher here managed to change their email address to max@example.com. The second misconfiguration is that they left the email attribute as case sensitive. So for Cognito, this one is different from this one. These are not the same email addresses because this one has capital M. So what they should have done is they should have set it to insensitive from the AWS console. So here in the second step, we have two misconfigurations. So now the researcher has their account set to max@example.com with a capital M. And the third step, the attacker, as I mentioned earlier, they try to log into their account with the newly updated email. So they logged out from the account and they logged in with the new email with the capital M. And here again, there are two misconfigurations. First of all, the application did not check if the email here was verified or not. So they did not check if email verified was set to true. And they just let in the attacker login. That's one misconfiguration. The second misconfiguration is that they haven't enabled the new settings, the new security setting that was recently introduced, which tells the Cognito not to update the email value unless the researcher has verified it. So what happened here is that they didn't check if the email it was verified, and they updated the email value before it was verified. And then the last part of the chain is that Flickr application, when the attacker, the researcher, tries to log in with their newly updated email, what the Flickr application does is they normalize convert the capital M to a small m, which means that now they get access to the victim's email address because they are using the small m email address. So another issue here is non-normalization because they converted the capital M to a small m, and this resulted in account takeover. So basically the researcher can access any account on the Flickr application as long as they have knowledge of their email address. So as you can see, this illustrates a bunch of misconfigurations that you can find in the wild if you're doing a pen test or if you're just doing bug bounties. The last security misconfiguration, it's not really a misconfiguration, it's actually a security vulnerability, is user account enumeration via the signup API. This is not a high risk security issue, but it's still part of the OWASP top 10, not top 10, it's part of the OWASP. It's basically if you're doing a pen test and you want to cover this as well. So, when you're setting up the AWS Cognito, you have the setting here to prevent user existence errors. This will mitigate user enumeration problems, which means that if you provide a valid username when you're logging in, but a bad password, the Cognito will not tell you if the user exists or not. So it will not be possible to enumerate the user on the login and the sign up part. The problem is that, so basically, when the prevent user existence errors is turned off, it says user does not exist. This is a user enumeration security vulnerability when it's turned on. But when you turn it on and you try to log in, it says incorrect username or password. So it does not tell you if the user exists or not. So basically, AWS, they fixed this user enumeration on the login part, but they mistakenly forgot to fix it on the sign up part. So basically, it is still possible to enumerate usernames or valid email address on the sign up process of the AWS Cognito. So this is still an open ticket on their GitHub. This is actually an actual security vulnerability that they haven't fixed yet. So you as a pen tester, you can enumerate valid usernames or email addresses on the application just by trying to sign up on the app using the AWS Cognito endpoint. So you can basically just execute this. This is a sign up operation. You provide it with the client ID, which you will find straightforward. You provide it with the username that we want to enumerate if it exists or not. This, we want to see if the admin exists. And you just give it like any password, any fake password here. So on the sign up, it will say user already exists, which means that this admin exists, and then you can just brute force credentials. So this is this is valuable if you're doing a pen test and you want to cover the user enumeration. You can also enumerate email. It depends what kind of attribute the application is using for identification. They might be using a username, or they might be using an email. If they're using an email, instead of enumerating a username, you can just provide an email. It will, again, if it exists, it will again say that the user already exists. So this is an enumeration problem. So basically, there is another misconfiguration that I haven't really included in the slides. It's like the access token is not, a lot of the times the access token that is being used for authorizing API operations is not being invalidated when maybe you log out for the application, it still remains active, or maybe when you reset the password, the access token still remains active, which is a kind of a broken authentication issue, and it's still a misconfiguration. It's a developer's mistake. I haven't included that in the slides, but keep an eye out for that. Always make sure that the access token is being revoked and invalidated once you log out from the application, or once you change your password, or once you reset it. So at the end, these are some recommendations for you as a developer if you want to make sure you don't you don't make the same mistake. First of all, you want to remove all the sensitive informations from server responses. If you can, just make sure not to hard code those IDs in the source code. Although they're not really sensitive on their own, but just make sure you hide them, as well as you can. Always make sure, if you don't need the sign up, self-registration, always make sure it's disabled in the AWS Cognito. As I showed you earlier, you have the right to enable or disable self-registration. So if you don't need users to sign up, make sure it's disabled. And also disable unauthenticated role if it's not required. Some applications, they do not really need guest access. They don't need to provide unauthenticated access. So make sure it's disabled in the console. Otherwise, anyone, even without having an account on your application, can be able to generate those AWS credentials, and then they can test them for whatever misconfiguration. You also want to review all the EM policies and permissions associated with the authenticated and the unauthenticated user role. Make sure they always stick to the least privilege access. Always give them the least access that they need. Nothing above that, nothing further. And then evaluate all the user attributes. When you're creating custom attributes, make sure if you want them to be writable, if you want the user to be able to control their value or not. Like earlier for the user role, you should not allow user to update it. So make sure it's not set as writable, it's only set as readable. And remember that the email attribute may hold unverified email address. This means that never trust the email address value. Always make sure that the email value is actually verified or not. Never trust it blindly. So these are some recommendations for you to not fall into the same mistake as I've shown you earlier. And that's it. Thank you so much for assisting. Appreciate it. Thank you. If you have any questions, let me know.
Any questions? Okay, there we go.
Perfect. Thank you. Appreciate it.